Okay, we can go ahead and mask up, and I'm gonna take roll today. Joseph Bentley, where are you? There you are. Okay. Thomas Britcher, Jaden, Tyler, Andrew, Drew Gotzel. Okay. Let's see. Michael. Is Michael Hagestead? Is he still? Okay. Kaisa. Jillian Jordan. It's getting a little more bold. I'm here. Luke. Okay, Luke's in there. Okay. Rachel. Anthony. Caroline. Vera McIntosh. Vera, go on. Lindsay. Andrew Nell. Emma. Thomas Rogers. Let's see. Michaela Stiles. Is Michaela? Sarah Strauss. Samuel. Parker. Okay, he's usually late, but Joseph Wagner. Sarah Wagner. Kaylin Walker. Aiden Wheeler. Mercedes Zimmer. All right. Okay. So last time we we finished this idea of Eric Lindahl's that what you ought to, if what you did was you charged people their marginal benefit at the place where the sum of the marginal benefits equals the marginal cost, then everybody would be happy with that output. If you tried to go more, then since you're at the point where if you have diminishing marginal benefits and you're paying that tax price, if you had people wanting to do more, then their tax price would be above their marginal benefit. And if you had people doing less, then their marginal benefit would be above their tax price, so they wouldn't want to do less, so everybody would be happy at where you were. Now, obviously, you can't probably do that, because how do I know what people's marginal benefits are, right? As we said before, you have an incentive to misreveal your preference if you know your tax price is going to depend on what your marginal benefits are. But nonetheless, it's just a point that if we again, there's no exact answer, but it gives you an idea what you'd be looking for if you were trying to get things to where you had unanimity. And then another idea of unanimity is by Wixell, and he wrote in 1896 a new principle of just taxation. A new principle of just taxation. And so, and again, he influenced Buchanan, and when you take, some of you had public choice, but when you do public choice, we spend a good deal of time on Buchanan and Tulloch's idea of, in the calculus of consent, where how you'd want people to vote on how much of a public good you would provide, et cetera. So the idea is that how does the, and we've talked about this several times here, in the private sector, if you have a private, right, you have a private good, what happens? Well, everybody pays the same price. We've talked about this numerous times. If everybody sames the price, and what happens? You can adjust the quantity. But in a pure public good, what's the problem is that you can't really vary the consumption. And so the question is, how can I get to unanimity? I mean, that's basically what his idea was. How can I get to unanimity? And the way that if you sort of thought about it, one way you could do that is you could vote on the tax and expenditure at the same time. It'd say, okay, here's what the tax is going to be, here's what the expenditure is going to be, and his idea is to vote on a tax expenditure at the same time. So we say, okay, we're going to spend this much on the good, and here's what the tax structure is going to look like. Okay? And if what you did was you made it so that you keep doing it over and over again until you get unanimity. That's sort of a general idea here, is that you keep varying this tax expenditure relationship until you get unanimity. Well, obviously, this is going to be hard to do. Clearly, when we talked about the Coase theorem, right? What do you have? You have high transactions costs, obviously. Right? Because you'd have to keep voting on this stuff over and over and over again. And if you sort of think about it, you know that you can block the output by voting no, right? And I'm pretty happy with this thing. And maybe what I would do is I would cut a deal with you and say, hey, you know what? I'll pay part of your tax, or I will pay you to vote yes or whatever, right? So there's, obviously, this point is that anybody could block the output if they vote no, and so you'd have, you'd have this very high transactions cost. Again, people misrevealing their preference or knowing that I could maybe persuade you to give me some money in order to vote for this thing that you want. So he suggested that you have near unanimity. Right? Sort of realize that, you know what, I'm probably not going to get complete unanimity, but the idea of near unanimity. Again, you're probably not going to do this. But notice that we do have what's called earmarked taxes in a number of places. So for example, state of Michigan, gasoline tax, right? And where does the gasoline tax money go? It goes to fix the damn roads, right? What our governor suggested when she was running for office. Okay, so you know that we have this combination of, and notice that in Michigan you also have a sales tax, and under the Constitution a certain fraction of the sales tax goes to fund K-12 education. Okay, so we do have this concept of combining the tax and expenditure together, and so it isn't exactly what Vixel was talking about. But he was just trying to point out is that, again, it's possible to come up with a theoretical solution to the problem, right? Conceivably, what I could do is I could just say, okay, here's the tax you got to pay, here's the expenditure on the good, and are you happy with that? And if we got to the point where everybody voted yes, then we'd say, okay, great. We've solved the same problem that is solved in the private sector by everybody paying the same price but adjusting what their quantity is. Basically, you'd be getting sort of like Lindahl to where you'd be at a point where everybody might be paying a different tax amount, but they end up all getting the same amount of the output. Again, it might work in a small group setting where you have let's say you have a neighborhood association and you're deciding how often people are going to plow the roads or when they're going to come down and plow the road, okay? And then you're going to know what you're going to pay in the neighborhood association dues. And so it might be that people might bargain with one another, or if you just had you have a road that goes into 3 houses or something, right? What might happen is you guys might all get together and say, okay, why don't we have the person come, when more than 1 inch of snow falls, and I'm willing to pay this amount, and the other person will pay that amount. So it's possible that you could get to that in a small group setting where what's going on, your transactions costs are lower. That leads us to an attempt to make it so that you would reveal your preference. And this is in the folder under famous readings, is what's called a Clark tax. And the idea is to get you to reveal your preference, right? To encourage you to reveal your preference. So how would this thing work? Well, the idea is you're going to get taxed the loss to everyone else in surplus of adding you to the total demand. Okay, let's draw a picture of that in a moment. But the idea is you're taxed the loss in surplus to everyone else by adding your demand. So let's just draw a picture of that. And if we put dollars up here and quantity of the public good there, and that's just for simplicity's sake, we'll assume constant marginal cost, just to make the picture easier. Okay, so here's the marginal cost of producing the public good, and the marginal cost is constant as we produce more of the public good. And what we're going to do is we're going to look at the sum of the marginal benefits, which includes you in it. And then we're going to look at the sum of the marginal benefits minus your demand, right? Because remember that what we're doing in a pure public good is we're adding the demand curves vertically, right? So we're adding the demand curves vertically. So that's the amount what we might call Q star here. But now let's take your demand out, okay? So if we took your demand out, this would be the sum of the marginal benefits minus, we'll call that the demand from the person I, and which is their marginal benefit, right? And if what we do is we put that down here, okay? If we put that down here, notice that what we're going to do is, what's your tax? Your tax is going to be, without you, where would we be? We'd be there, right? We'll call that Q star minus I. So if we took your demand curve out, this is where we'd be. Like if we had our group and we just didn't include you, where would we end up? we'd end up with the sum of our marginal benefits equals the marginal cost, and we'd end up there. Instead, when we add you, we're going to end up over there, right? So what are we going to charge you? We're going to charge you that loss and surplus, because for every unit, for the rest of us, every unit between Q star minus I and Q star has got a marginal benefit which is less than the marginal cost, right? For us, right, all those units between here and here, the marginal cost is up there, but our marginal benefit is down here, and so, right, that is going to be what our loss and net benefit is, okay? So if I put the sum of the marginal benefits minus you, we're just not including you in the vote, okay, or not including you in the process, then this is where is optimal for us. But when we add you, right, we add your demand curve, it's going to move the total demand curve up to here, and so the sum of the marginal benefits for everybody, including you, that amount's going to be here. So the problem for the rest of us is we're losing consumer surplus here by the idea that for each of us, any movement from this amount to this amount is got marginal costs which are above our marginal benefits, right? This line doesn't include you. If what we did was we charged you that, then what would happen is that we would end up with you paying a tax that looked like that, right? Your tax would be going that way, which is this amount here. And at that point, notice what happens is at that point where we hit the Q star, what's going to happen is that for every unit from here to here, your marginal benefit is above the tax price to you, which is the loss to here. And when we get here, right, that's where the sum of the marginal benefits is just equal to the marginal cost. So your demand curve must hit this amount here is this amount there. So at that point, any point to the left of that, you'd be wanting to go ahead and pay the tax. So under a Clark tax, what happens is you would be happy at Q star if what happens is your tax price is equal to that loss to everybody else. And whereas if you go one more unit, then what's going to go on is the tax price to you, the loss to you in terms of a tax price is going to be bigger than the marginal benefit to you, because the marginal benefit to you is in this demand curve. So the idea of the Clark tax is to have everybody pay the net loss between the marginal cost and the benefits to everybody else without you, and then with you, okay? So the trick here is not to use the tax to pay for the pure public good, right? The purpose of the tax is to get you to reveal your preference. Right? Is to give you an incentive to reveal your preference. Right? You're willing to say, you know what? I'm willing to pay that tax price and get that amount of the public good, right? Because anywhere to the left, I've got a benefit which is above the loss to everybody else. But once I get to the Q star, then any amounts that go above that, I've got a bigger tax price. The loss to everybody else from going beyond that is greater than the tax price to me, and so I'm not going to reveal my preference. Yeah.
Are these
Well, this is for a pure public good, right? This is for a good where, this is how you solve the problem of a pure public good. I mean, what's the problem, right? The problem is that everybody gets the same amount of it. It's difficult to exclude, and it's non-rival in consumption. Okay, how do I get a system whereby we all get the same amount, but we all have different prices, right? I mean, that's the deal. I mean, that's the big picture is private goods. You guys all change the amount of Gatorade bottles that you're buying, and you all face the same price. So you can vary the Q to where you get the marginal benefit is just equal to the marginal cost to you. But I can't do that in the pure public good, right? In the pure public good, if we get 15 units of national defense, I get 15 units and you get 15 units, there's not a mechanism where I only get 3, right? So I got to have a mechanism that changes the price for each of us so that their marginal benefit is just equal to the tax price that they're doing it. And that's what the Clark tax is doing. It's getting you to, we're going to get to that point where what Lindahl had suggested, right? You get the Lindahl tax for everybody. Everybody's paying their tax price where their marginal benefit is just equal to their tax price at where the sum of the marginal benefits equals marginal cost. What Clark is doing is trying to get you to overcome this incentive to misreveal, to say, hey, I don't want it at all, right? Because you could do that here. Remember we were saying that under Lindahl, you could say, hey, I don't want it at all, and you'd get what everybody else did without you, and you'd get that amount for free, okay? But here, what happens is if you say, okay, if you misreveal and you say, hey, I don't want it at all, well, then what will happen? If you say I don't want it at all, you're going to end up here, right? But every unit from here to here has a marginal benefit to you, which is greater than what your tax price is going to be, okay? So as I move along this direction, my tax price is going up. And where am I going to stop? I'm going to stop where this amount is that amount, right? Because that's what this is, right? Your demand curve is adding to the is adding to get to the sum of the marginal benefits, okay? So anyway, the point of the Clark tax is not to pay for the tax, or excuse me, pay for the good. The point of the Clark tax is to make it so that you guys have an incentive to reveal what your preference is. And if we all are out there, if we all do it that way, then what's going to happen? We're all going to reveal our preference, right? The trick is, again, if you were to truly implement it, how would I know what the sum of the marginal benefits is with you and the sum of the marginal benefits is without you, right? I mean, again, it's not that there's that somehow, yeah, this is the right way to do it, right? But it leads you to this idea that we at least have a theoretical solution to the problem. Do we have a way to implement that? Well, you got to think through whether you really have a way to implement that. But it at least tells you what the optimal solution would be. Is that clear? Okay. Again, if you look in Clark's paper is in the famous readings folder within, unless I've moved it, I'll have to figure that out. All right. If it's not in the famous readings, then I moved it into the public good folder. So look in both places. All right. That leads us to another way to look at what's going on with public goods, and this is the idea of Bowen and his analysis of majority vote. And this is in chapter 5 of Hyman. You know, I said that Hyman has some things that he's put in that chapter 5, which is the public choice section of it. And again, we cover this in public choice as well. But the idea is that we're going to get to the point where we'll end up, basically what it's going to show is that under majority vote with equal cost shares, you're going to end up with the Samuelson condition. Remember, the Samuelson condition says, what's the optimal place to be? Where the sum of the marginal benefits equals the marginal cost, right, for a pure public good. So for a pure public good, sum of the marginal benefits has to equal the marginal cost. How can I get there? Okay? And what Bowen showed was that under certain conditions, just majority vote will get you to the right amount. Okay? Won't get you to the right tax price, but it'll get you to the right amount of the pure public good, where the sum of the marginal benefits equal the marginal cost. So, what's the assumption? Well, first of all, we're going to assume that we have equal cost shares. That is, everybody is going to pay the same cost of the public good. I'm going to pay the same amount that you do, right? So everybody's going to pay the same amount. Okay? Now, again, we know that that's not going to get you to the Lindahl position, right? But we're going to assume that everybody pays the same amount, and we have a normal distribution of preferences. So we have a normal distribution of preferences. And why would we assume that? Okay. What's true about the median and the mean of a normal distribution, right, from Econ 206? You must know, right? There's something about normal distribution of preferences that relates the median to the mean, yeah. Yeah, they're the same thing, right? The median equals the mean. If you have a normal distribution, actually if you have a uniform distribution, but if you have a normal distribution, the median and the mean are the same spot, right? So the trick here, that why I assume this, is because the median equals the mean, okay? So let's assume that we, just to make the picture look easier, let's assume that we have a constant marginal cost, right? So we got Q here, and we've got dollars here. And what we'll assume is a constant marginal cost. And if we assume equal cost shares, let n be the number of people, number of voters anyway. So everybody's going to pay the same, right? Everybody's going to pay the marginal cost over n. So if we look at it that way, then what we can do is we can say, okay, what's person one's demand for the public good? All right, so let's let D1 be person one's demand, and D2 is person two's demand for the public good. And here's D3, and we'll make 5 people so that we can have, so we can have and if we have an even number, then you have to, that's around. But we're going to make 5 people, so there's clearly somebody that's in the middle, right? So now let's think about it for a minute. Let's look at what the median voter would vote for, right? How much Q would the median voter vote for? So this is the median voter here, right? So the median voter is going to end up with, we'll call that QM, which is what the median voter wants. because their marginal benefit is above their tax price, right? So MC over N, that's their tax price. And the demand is their marginal benefit. So as we're going along here, where is the median voter going to say they want to stop, right? They're going to want to stop here because units to the left of QM, the marginal benefit for the median voter is above the tax price, right, which is their marginal cost. So they'll vote for units going anywhere to the left of QM, and to the right of QM, they're going to vote against it because they've got a marginal cost, their tax price, which is bigger than their marginal benefit. So at QM, what's happened? The median voter, who is D3 in this example, their marginal benefit is equal to their tax price. And so this is where it's optimal for them. Now let's see what would happen if you tried to move to the left of that, right? Suppose you had a vote on Q less than QM. Okay? So vote Q less than QM. Well, to the left of QM, if you were to try to move that way, okay, if we started here and we try to move to the left, then what would happen? Then the median voter wouldn't want that, right, because their marginal benefit's above their tax price. D4, their marginal benefit is above their tax price. And D5, their marginal benefit's above their tax price. So 3 would vote against moving from QM. These two people, D1 and D2, they'd vote for it, right? So if you were to vote for Q less than QM, we'd have D3, D4, and D5 would vote no, and D1 and D2 would vote yes. So it would lose 3-2, right? So if you picked trying to make more, right? Suppose you wanted to do QM bigger than, Q bigger than QM. Then what's going to happen? If I try to make it this way, D1 and D2 are going to vote no, right? Because their marginal benefits are already below their tax price. But for D3, they'd vote against it too, right? To move to the right because their marginal benefit is less than their tax price. So if Q bigger than QM, we'd have D3, D2, and D1 would vote no, right? Their marginal benefit is less than their tax price. D4 and D5 would vote yes, but it doesn't matter, right? So it's 3-2. So it would lose 3-2. So the first thing to notice is that whose vote is going to determine the outcome? The median voter's vote is going to determine the outcome. And again, when if you take public choice, we talk quite a bit about median voter theorem and the like. But if they have any kind of if you have a normal distribution or any kind of distribution where the median equals the mean, that's the trick. Okay? The trick is I'm going to assume some distribution of preferences where the median equals the mean. Why would I assume that is because I'm going to show you that when the median equals the mean, you get the Samuelson condition. Okay? The median voter is going to determine the outcome whether the distribution of preferences is normal or not here, right? The person that's at the median in the middle, if you have a majority vote just between two options, right? More than QM or less than QM, the median's always going to determine the outcome. But the trick here is to show that the median equals the mean. Now, what is the mean? The mean is the sum of the demand, right, divided by the number of people, right? But what are the demand curves? That's the marginal benefit curve, right? Right? Your demand curve for anything is your marginal benefit curve, if you go think back to 202. So what is that going to be, though? This is also the median. And so what's going to happen here is that where are we here? We're at MC over N, right? So we've got MC over N is what we have the tax price, and at Q star, we're at the median, or excuse me, we're at the mean, right? At Q star, we're at the mean. So at Q star, what do we have? We have the sum of the marginal benefits over N is equal to the marginal cost over N, right? Because this is the demand curve, and that's equal to MC over N because this is the median, right? This is the median as well, right? So the median at the median voters QM, what's going on? The median equals the mean. The mean is this, but that's that, right? Because we're at this point. And so what does that tell you? Multiplying both by N, we're going to get the sum of the marginal benefits is equal to the marginal cost, right? And that's the Samuelson condition, right? The sum of the marginal benefits has to equal the marginal cost. So Bowen's, if we look at Bowen's model, if you assume that we have equal cost shares, and we assume that you have a normal distribution of preferences, and that assumption is to get you that the median equals the mean, then what's going to happen is the median voters preference is going to win, right? And that median voters preference at that point is going to be the point where the mean, which is the median voters preference, is also the mean. And the mean is the sum of the demand curves divided by N, but that's the sum of the marginal benefit curves, marginal benefits divided by N. And that is going to be equal to that's why we made equal cost shares, right? That's why we didn't do that just out of the blue. So the equal cost shares are MC over N. And so what do you end up with? The sum of the marginal benefits over N is equal to MC over N, which is everybody's tax price. But that means that the sum of the marginal benefits equals the marginal cost. And that gives you the Samuelson condition. So what did Bowen then, the Bowen model says, you know what? We're going to end up with an efficient amount of the pure public good if what we do is we just let people vote on it, right? And the majority vote wins. And you guys decide how much you're going to do it by, okay, if I keep increasing Q, I keep increasing Q until what? Till I get to any movements farther to the right will end up with a majority voting no. As we keep moving to the right, we're going to have a majority voting to increase Q. Boom, we get to where the majority, the median voters' preferences are. That's where you stop. You don't keep going. And at that point, you're going to have the Samuelson condition. Notice that you don't have Lindahl here, though, right? Because everybody's paying the same tax price. And so, and you don't have unanimity, right? Lindahl and Vixel were about getting to unanimity. What was Bowen about? Bowen was about getting to the optimal amount, okay? So everybody is paying the same tax price, so they can't be at a point where there's not unanimity, right? This person's tax price is above their is above their marginal benefit. D1's tax price is above their marginal benefit. D4 and D5, their marginal benefit's above their tax price. Right? The only person who's getting where their marginal benefit equals their tax price is the median voter. But trying to move from that spot ain't going to happen. Okay? Movements from that spot will be opposed by a majority. Okay? Right? So, not rocket surgery here, right? So, okay. Again, if you look at the old exams, that I put a couple of the old exams on, old midterms on there, and you can see that what I'd like you to do is I'd like to be able to take these models and just explain them briefly, and use Rod Stewart's "Every Picture Tells a Story." So be able to draw the little diagram and explain it to somebody else. In fact, if you can explain it to your parents, and you get them they're all excited about it, right? You call them, "Hey, do you really like to talk about the Bowen model?" And you can do that, then you should do well on the midterm. All right. The last thing that we're going to talk about is Buchanan's theory of clubs, and we may not finish it today, but it'll give you an idea of what happens if you have a good. Remember, we said that goods lie along a continuum, right? That is, some goods are purely private. Eating a hot dog, I can't eat that hot dog. Whereas some goods have some sharing to them, but if you start to use it a lot, then maybe, or a lot of people start to use it, then it becomes congested. So you might have this big swimming pool, and first person gets in, then another person gets in, and they're down at the other end of the pool, or whatever. So it may be that at the beginning, it has this characteristic of a pure public good, is that you're swimming in the swimming pool doesn't bother me when, it isn't affecting me. But as you get more and more people in the swimming pool, what happens? You start to congest. My consumption of the swimming pool is affecting your consumption of the swimming pool. So we said that goods tend to lie on continuums between purely private and purely public. And so what Buchanan is doing is looking at what happens with goods where you get congestion, right? They have some aspect to it where at the beginning, my use of it doesn't affect your use, but after a while, the more people that we add, my use affects you. But also, I have to decide how big is the swimming pool going to be, right? If I have a really big swimming pool, then it doesn't have as much congestion. If I have a little, wading pool, my use of it is, there's going to be congestion. And so as I build the swimming pool bigger, then what happens? I reduce the congestion. It begins to look more like a pure public good, but then there's a cost to it, right? And if we're going to share the cost, I got a problem that, or not a problem, but what's going to be happening is that as I increase the size of the swimming pool, the cost per person is going up, but the congestion per person's going down. Okay? So what you got to do is solve both problems. How many people do I want to have in the club, and how big do I want to make the swimming pool? Okay? So what Buchanan's theory of clubs is an analysis of that. So what Buchanan looks at is suppose we have equal cost shares. That is, we're all going to pay to get into the club, right? So the club's going to pay for whatever the facility is, whether it is a golf course, or whether it's a swimming pool, or whether it's a roadway, or whatever it is, okay? So, and we're going to share that. We're going to have equal cost shares. And we're going to look at the benefit per person. And we're going to look at the cost per person. So I've got a benefit per person and a cost per person. And what we're going to assume is, what we normally assume, right? We're going to assume that you have diminishing marginal benefits, right? And increasing marginal cost. But let's look at it this way. Suppose that I was looking at Q, let's make Q. Yeah, let's make it N, where N is the number of people in the club. So N is the number of people in the club, and we're going to have a fixed quantity. So we got a fixed swimming pool size, right? Or we have a fixed I don't know, size of the golf course or something like that, okay? And so, a fixed clubhouse or whatever. So we've got a fixed amount of the whatever we're talking about. And so how do I'm going to start letting people into the club. And notice that the cost per person is going down as I let people into the club, right? So I've got the cost per person is going down as I add members. But the benefit per person, that's going down as I add members. So if I were to put dollars here, and I would draw a picture, I would have the benefit per person would look like this. Given the size of the swimming pool, as I add more people, what's going to happen? The benefit per person is going to be declining, right? And if you draw it this way, every picture tells a story, right? So if I draw the picture that way, the story must be that the benefit per person, the congestion is getting greater, right? The benefit per person is going down, and it's going down at a faster rate. So at the beginning, decent sized swimming pool, add a few people, benefit per person is going down, but as we get more and more and more people, they start splashing on one another and all sorts of stuff. And so the benefit per person is going down faster as N goes up, right? And what are we going to assume? We're going to assume the cost per person. We're going to assume the cost per person is going down, is going like this, but it's flattening as we move out. And that makes some sense in that if you think about it, if you only have one person in the club and another person comes in, the cost per person went down by half, right? But if you have 100 people in the club and you add one more person, then the cost per person didn't go down nearly as much when you add the 100th person as it did when you added the first person. So that makes logical sense. So if we were to tell the story, it says, okay, as I add more people to a fixed size of the swimming pool, if I add more people, the benefit per person is declining, and it's declining faster as we get more people in the club. The cost per person is going down, but the cost per person is going down less as we add more people. What am I trying to do? I'm trying to maximize that difference, right? I'm trying to maximize the difference between the benefit per person and the cost per person. And of course, where is that going to happen, right? It's going to happen where these slopes are equal. So what we'll do for Friday is we will work our way through this. What we're going to do is we're going to figure out just what we just did, right? That you keep adding people as long as the benefit per person is the decline in benefit per person is less than the decline in the cost per person. And then we're going to say, okay, given the number of people, how big do you make the facility? And what will that do? You'll end up with two equations and two unknowns. You can solve it. All right? So for next time, do that. And then we're going to start chapter 10. So we'll definitely finish theory of clubs. So go ahead and read at least, partway through chapter 10 to give you an idea of what we're talking about.